A star does not vanish for no reason. It can flicker. It can pulse. It can dim for a few hours when a planet crosses in front of it, leaving behind a clean, mathematical shadow. That is how many distant worlds are found, not by seeing the planet itself, but by noticing that the star briefly loses a little light. But in 2007, a young star in Centaurus did something that did not look clean at all. Its light began to fall in pieces. Not once, not smoothly, not like a single planet sliding across a glowing disk. For weeks, the star seemed to move behind something ragged and enormous. Something with dense regions and thin regions. Something with spaces inside it where the light briefly returned before being swallowed again. The event lasted for roughly 2 months. And when astronomers later studied the pattern, one possibility rose from the data like a shape emerging behind fog. Perhaps this star had been eclipsed by a hidden companion, surrounded by a ring system larger than anything humanity had ever imagined around a planet-like object. The proposed companion became known as J1407b. Online, it is sometimes called the planet with rings bigger than a solar system. That phrase is powerful, but it is not quite true. The proposed rings were not bigger than the entire solar system. One model estimated them at about 0.6 astronomical units from the companion, around 90 million kilometers. That is still almost impossible to hold in the mind. It is wider than Mercury's orbit around the Sun in scale. It is so large that Saturn feels like a small, finished sculpture beside a cosmic construction site. But the most important word in this story is not rings. It is proposed. J1407b has not been photographed as a clear planet. Its orbit has not been pinned down with the certainty of a familiar exoplanet. No telescope has given us a beautiful image of a giant world wearing an impossible crown. What we have is stranger and more fragile, a shadow recorded in starlight, a pattern so complex that scientists had to ask what kind of object could make a star flicker for weeks. That is where the real story begins. J1407 is not an old, settled star like the Sun. It is young. Its system belongs to a messier chapter of cosmic history, when planets may still be forming, debris may still be clearing, and moons may still be gathering out of disks of dust and rock. Around mature planets, rings can look like decoration. Around young giant worlds, they may be something else entirely. They may be raw material. They may be the early shape of moons. If the ring interpretation is correct, then J1407b was not simply wearing rings the way Saturn does. It may have been surrounded by a circumplanetary disk, a vast rotating field of matter caught between chaos and architecture. Inside that disk, gravity could have been sorting the material, clearing lanes, gathering clumps, carving gaps. A ring gap is never just empty space. Sometimes it is a signature of an unseen body. Around Saturn, small moons shape ring edges and help open divisions. Their gravity tugs at particles again and again, quietly organizing the chaos. So when the 2007 light curve of J1407 showed patterns that could be modeled as rings and gaps, the idea became irresistible. Perhaps those gaps were signs of moons being born, not moons we could see, moons inferred from missing light. Imagine standing in a dark room with a lamp on the other side of a curtain. You cannot see what is behind the curtain, but as something passes between the lamp and the fabric, its outline presses briefly into the glow. If the shadow has holes, edges, and repeating structures, you begin to reconstruct the invisible object from the way it interrupts the light. That is what the star became. A lamp, and for a short time in 2007, something crossed in front of it that seemed to carry structure on a planetary scale. Saturn's rings look eternal in photographs, as if the planet has always been framed by that luminous disk. But rings can spread, darken, collide, gather, and disappear. They are not jewelry. They are motion frozen only by the shortness of a human lifetime. Around a younger, larger, less settled object, a ring system could be wilder. It could be thicker, heavier, less polished. Instead of icy bands arranged like a finished ornament, it might be a moon-building disk, full of material that has not yet decided whether to remain as rings or become worlds. That is why J1407b captured the imagination. It was not only big, it seemed unfinished. It offered the possibility that we were not looking at a planet's decoration, but at the workshop where satellites are assembled. The scale changes everything. A ring system stretching tens of millions of kilometers would not feel like a narrow halo from nearby. It would feel like a landscape. A spacecraft drifting through it would not see a simple band. It would pass through broad regions of dust and debris, darker gaps, and denser lanes where countless particles moved around a hidden central mass. From Earth, all of that collapsed into a single measurement, the brightness of a star. A little less light, then more, then less again. A coded message written by shadow. But every message has to be decoded carefully. A beautiful interpretation can still be wrong. A model can fit a signal without being the only possible explanation. And J1407b is especially difficult because the event has not repeated in a simple, obvious way. If a giant ringed companion is orbiting the star, then eventually it should return to the same line of sight. Another eclipse should happen, depending on the orbit. Astronomers have watched and searched. They have looked through older records and newer observations. They have tried to find the companion directly. The clean return has not arrived. That absence does not erase the 2007 eclipse. It turns the discovery from a portrait into a question. The question is no longer just how a planet could have rings so large. The deeper question is what kind of object can cast such a complicated shadow once, and then hide from every attempt to find it again. This is where J1407b becomes more than a super Saturn. It becomes a test of how much we can trust a shadow when the object that made it remains unseen. Perhaps the companion is there, moving on a long or unusual orbit. Perhaps it is massive, closer to a brown dwarf than a planet. Perhaps the disk is not stable in the simple way people first imagined. Some dynamical studies suggest that if such a huge ring system exists around a companion on an eccentric path, it may need unusual conditions to survive, such as retrograde motion around a massive object. The meaning is simple. A ring system that large is not easy to keep. A star's gravity is not gentle. If a companion swings too close, the star can pull at the outer material, stripping or disturbing it. What looks elegant in an artist's impression may be fragile in real celestial mechanics. The bigger the ring system, the more it has to survive. And yet the shadow remains. Somewhere in the record of that young star, the light still falls and rises in strange steps. The data still asks for an explanation. The model still tempts the imagination, and the universe still holds back the object itself. J1407b is not a certainty. It is a shadow with a name. And sometimes, in astronomy, a shadow is enough to change the size of what we think a planet can be. To understand why the shadow mattered so much, you have to forget the way rings appear in finished photographs. Saturn has taught us to see rings as delicate, almost peaceful things. They look flat, bright, and impossibly orderly, as if some careful hand placed them around the planet. But that is a mature view of a ring system. It is what we see after time has done much of the editing. A young ring system may be less like a crown and more like a storm. Particles collide. Dust spreads. Pebbles clump. Larger fragments disturb smaller ones. Gravity gathers material in some places and clears it from others. The whole structure is moving, grinding, sorting itself, trying to become something more permanent. Around a forming giant planet, this kind of disk can be the place where moons are assembled. That is why the proposed rings around J1407b were so startling. Their size was not the only strange part. Their possible meaning was even larger. If the 2007 eclipse really was caused by a companion with a huge disk, then the event may have given us a rare glimpse of a process we almost never catch directly, a planet-like object building a family of moons. In our own solar system, the big moons of Jupiter and Saturn are already finished enough to seem inevitable. Ganymede, Titan, Europa, Callisto, they feel like permanent worlds, but they were not placed there fully formed. They came from material moving around young giant planets, from disks of gas, dust, ice, and rock shaped by gravity over time. J1407b may represent that earlier phase, not as a clean diagram, but as a messy silhouette. The star's dimming pattern was like a barcode written in darkness. Each drop in brightness hinted at a denser region. Each recovery hinted at a thinner region or a gap. Instead of one smooth transit, the event looked layered. That is why astronomers could attempt to reconstruct a set of rings from the light curve, as if the star had become a scanner reading the structure of an unseen disk. But reconstruction is not the same as direct vision. No telescope watched J1407b drift across the star as a crisp object. No image revealed the ring plane. The model came from the way light changed over time. That makes it powerful, because astronomy often works through inference. But it also makes it vulnerable, because a complex signal can sometimes have more than one possible cause. Still, the ring model had a haunting elegance. A large companion passed in front of the star. Around it was a wide disk. Inside that disk were regions with different densities. As the disk moved across the star, it blocked light in a sequence. The star's brightness became a record of the disk's structure. If that interpretation is even partly right, the scale is difficult to exaggerate responsibly. A radius of around 0.6 astronomical units means the proposed ring system would extend tens of millions of kilometers from the companion. For comparison, Earth is 1 astronomical unit from the Sun. Mercury orbits at about 0.39 astronomical units. So this was not a Saturn-like ring system made slightly larger. This was an object whose surrounding material may have reached across a distance comparable to inter-planet orbits. A human spacecraft inside such a system would not experience it as a ring. It would experience it as a region of space. The central object might be far away, hidden behind lanes of dust and debris. The ring plane could stretch so widely that its curvature would be impossible to feel at once. There would be no single spectacular postcard view, no neat glowing hoop. Instead, there might be a vast, flattened environment, a dark celestial plane of moving material, thin in some places, crowded in others, with gaps wide enough to hold entire gravitational stories. And within those gaps, the most exciting possibility appears. A gap can be a wound. It can also be a footprint. If a young moon orbits inside a disk, its gravity can disturb nearby particles. Over many orbits, it can help clear a lane, pushing material away from its path. The result is an absence that points to a presence. You do not see the moon. You see where the moon has changed the ring. That idea gave J1407b its deeper emotional force. It was not simply a planet with absurdly large rings. It was a possible moon nursery, an alien construction zone caught at the moment before the architecture became obvious. The viewer's first instinct is to compare it with Saturn, but that comparison may be misleading. Saturn is the polished fossil of a later stage. J1407b, if real in this form, would be closer to a beginning. It would show matter still negotiating its future. Some of it might remain as rings. Some of it might fall inward. Some might escape. And some might gather into moons, turning a temporary disk into a permanent system of worlds. This is what makes young planetary systems so different from the calm clockwork we usually imagine. We inherit the solar system after the violence has mostly faded. The planets are separated. The moons have settled into recognizable paths. The debris has thinned. The great collisions are rare. But early on, a planetary system is not a finished machine. It is a work site. Dust becomes stones. Stones become embryos. Embryos disturb disks. Disks feed planets. Planets shape moons. Everything is moving through stages, and most of those stages vanish long before anyone can observe them. J1407b may have offered a brief look into one of those vanished stages. That is why the uncertainty is not a weakness in the story. It is the story. The shadow may be telling us about a giant ring system, or it may be exposing a different kind of object, a different geometry, a rarer alignment, a puzzle we have not solved. But either way, it reminds us that a single star's brightness can contain an entire hidden architecture. The danger is turning the hypothesis into a myth too quickly. Once people hear rings bigger than a solar system, the careful science disappears behind the spectacle. The actual claim becomes inflated until the mystery sounds settled, and the uncertainty feels like an inconvenience. But the truth is more interesting than the exaggeration. A proposed ring system about 90 million kilometers in radius, inferred from a strange eclipse, around an object that has not been cleanly recovered. That is already astonishing. It does not need to be made bigger than the solar system. It only needs to be understood for what it might be. A young world, or something heavier than a world. Surrounded by material so vast that its shadow turned a distant star into a coded message. A possible disk where moons were not yet moons, a structure too large to fit our Saturn-shaped intuition, and too uncertain to become a simple fact. In that tension, J1407b becomes unforgettable. Not because it gives us a clear answer, because it shows how much can be hidden inside a shadow. The deeper problem with J1407b is not that its proposed rings are large. The deeper problem is that large rings are difficult to protect. A ring is not a solid object. It is a crowd. It is countless particles sharing a broad path around a central body, each one obeying gravity, each one colliding, drifting, and responding to every tug from nearby masses. From far away, the ring may look smooth. Up close, it would be a moving population of fragments, more like weather than architecture. That means a giant ring system is not simply a thing that exists. It has to survive. Around Saturn, the rings are held close enough that the planet's gravity dominates them. They are enormous to us, but they sit in a region where Saturn can still command the motion of the particles. Around J1407b, the proposed disk would have stretched vastly farther outward. The farther material lies from its companion, the easier it is for the parent star to interfere. Gravity weakens with distance. A particle at the outer edge of such a disk would feel the companion's pull less strongly than material close in. It would also feel the star's pull, and the changing geometry of the orbit could disturb it again and again. This is where the beautiful picture becomes physically tense. If the hidden companion was orbiting J1407 on a long, eccentric path, then it might spend part of its orbit far from the star and another part much closer. During the closer passage, the star's gravity could stretch and strip the outer disk. A ring system that looks majestic in an artist's image could become vulnerable in motion. The outer regions might not last. They might be torn away, warped, or rearranged. So astronomers had to ask a harder question. Could a disk that wide remain bound to the companion long enough to explain the eclipse? Some models suggested that ordinary arrangements struggle. If the ring particles orbit in the same general direction as the companion travels around the star, the outer disk can become unstable under stellar tides. But if the material orbits the companion in the opposite direction, a retrograde configuration, it may survive better. That does not prove J1407b has retrograde rings. It only shows the kind of unusual physics the system may require if the ring interpretation is right. This matters because science is not only about finding a model that fits the data, it is about asking whether the model can live in the real universe. A giant disk may explain the shape of the shadow, but then the disk has to obey gravity. It has to survive the orbit. It has to avoid being shredded too quickly. It has to be massive enough, or young enough, or arranged strangely enough to still be there when the eclipse occurred. Every solution opens another door. If the companion is very massive, perhaps closer to a brown dwarf than a planet. Its gravity could hold a wider disk. But then the story changes. We are no longer imagining simply a super Saturn. We are imagining an object near the border between planet and star, heavy enough to behave differently from the worlds we know. If the disk is young and temporary, perhaps it did not need to last for billions of years. It may have existed only during an early stage, while material was still gathering and clearing. Then, the 2007 eclipse becomes even more precious, because it may have caught a short-lived phase, not a permanent feature. If the object was not bound to the star at all, the problem changes again. A rogue planet or brown dwarf with its own disk could have drifted across our line of sight by chance. In that case, there would be no repeat eclipse, because there is no orbit around J1407 bringing it back. The object would simply move on, carrying its darkness elsewhere. That possibility is rare, but it has a strange elegance. It explains the missing return by making the original alignment accidental. The star did not have a ringed companion. It was photobombed by a wandering object with a disk. But rare explanations demand caution. Space is wide. Alignments are unlikely. A one-time crossing would need the right object, the right disk, the right speed, and the right geometry. It is possible enough to discuss, but not comfortable enough to declare. This is the rhythm of J1407b. Every answer becomes unstable when you press on it. A bound companion explains why the object was near the star, but struggles with the missing repeat in the survival of the disk. A free-floating object explains why it never returned, but requires a chance alignment that may be unlikely. A giant ring system explains the complicated dimming, but later searches have not produced the simple confirmation everyone wanted. The mystery survives by refusing to become one clean thing. And this is where the story becomes more scientifically valuable than the popular headline. The headline says there is a planet with impossible rings. The science says something subtler. A young star produced a strange, structured dimming event, and one of the most compelling explanations points toward a huge disk around an unseen substellar object. But the object remains difficult to find, and the interpretation remains under pressure. That pressure is not a failure. It is how astronomy matures. The first model gives the imagination a shape. Follow-up observations test that shape. Dynamics asks whether the shape can survive. Non-detections carve away easy versions of the story. Each new constraint makes the truth smaller in some places, sharper in others, and sometimes stranger than the first idea. For viewers, this can feel frustrating. We want the universe to deliver clean revelations. Here is the planet, here are the rings, here is the final answer. But much of real discovery lives in the space between signal and certainty. J1407b is not a museum object. It is an investigation still echoing from old data. And perhaps that is why it stays with us. Because a confirmed giant ring system would be magnificent. But a possible one is more haunting. It asks us to imagine something enormous, then asks us to earn the right to believe it. It forces awe and skepticism to occupy the same room. In that room, Saturn becomes smaller. Not physically, but conceptually. Our familiar example of rings no longer defines the category. It becomes one calm island in a much broader sea of possibilities. Rings as debris fields, rings as moon nurseries, rings as temporary disks, rings as shadows so wide they can make a star flicker for weeks. J1407b may not be the clean, super Saturn of the internet myth. It may be something more difficult. A lesson in how young worlds are built. A warning about how easily wonder can overrun evidence. A reminder that the biggest structures are sometimes first seen not by their light, but by the light they remove. The reason astronomers kept returning to J1407 was simple. A shadow this large should have a source. Something moved across the star in 2007. Something changed the light in a way that looked structured, layered, and prolonged. If that something was a companion with rings, then it was not a tiny hidden rock. It had to be a planet-like or brown dwarf-like object massive enough to carry a disk. and that should leave other traces. So the search became a second story, layered on top of the first. The first story was the eclipse itself, the ancient signal in the brightness record, the jagged fall and rise of starlight, the possibility of a disk so wide it turned a star into a flickering lantern. The second story was quieter, and in some ways more frustrating. It was the attempt to find the culprit. Astronomy often begins with absence. A star dims, a spectrum shifts, a point of light moves against the background. From those small changes, entire worlds are inferred. But after inference comes pressure. The hidden world must keep making sense when you look again, from another angle, with another instrument, in another wavelength. J1407b had to survive that pressure. If it was bound to the star, then it should be somewhere along an orbit, maybe far away, maybe faint, maybe hidden close to the glare of the star. But still, somewhere. Astronomers could search for extra light from a companion, for infrared warmth, for motion, for another dimming event. They could ask whether the companion should have been visible at certain times, whether an orbit would bring it back, whether old plates or modern surveys had missed another eclipse. Each non-detection narrowed the easy versions of the story. This is not the same as proving the ring model false. A non-detection depends on sensitivity, timing, wavelength, assumptions about mass, temperature, dust, and orbit. A companion can be too faint, too close to the star, too cold, too distant, or simply in the wrong place when the telescope looks. But non-detections matter because they remove room. They make the mystery less comfortable. A confirmed planet often grows more solid with every new observation. J1407b grew more conditional. The phrase super Saturn spread because it gave the object a shape people could imagine. But the real object, if it exists, may not resemble Saturn in any familiar way. Saturn is a mature gas giant with a beautiful, thin ring system inside a well-known orbit around the Sun. J1407b may be a massive young companion, or a brown dwarf, or an unrelated passing object, or something whose disk existed only briefly. The nickname is useful as a doorway, but dangerous as a destination. Because Saturn is easy to love. J1407b is hard to confirm. The difficulty begins with distance and brightness. A young star can be active. Its light can vary for reasons that have nothing to do with planets. Star spots, accretion, dust, and stellar behavior can complicate the record. When the signal is a single event, the challenge becomes sharper. You cannot simply wait for a neat rhythm and stack repeated transits until the noise fades. You have one strange passage and a long silence afterward. That silence is part of the data. It says either the orbit is long, the geometry is rare, the object is not bound, or the original interpretation is incomplete. None of those options is simple. A long orbit could explain why the eclipse is not repeated, but it may require the companion to be far from the star for much of its path. An eccentric orbit could bring it close enough to create the observed event, but then the giant disk faces stronger tidal disruption. A chance alignment could explain the lack of repetition, but asks us to accept a rare crossing by an unrelated object. The universe allows rare events. It does not allow us to call them common without evidence. So J1407b sits in an unusual category. It is famous because of what it might be, but scientifically important because of how hard it is to prove. It shows the difference between a compelling model and a secure discovery. A compelling model says, this pattern could be explained by a giant ring system. A secure discovery says, we have found the object, constrained its orbit, confirmed its nature, and shown that the interpretation survives follow-up. J1407b has lived mostly in the space between those statements. That space is not empty. It is where much of frontier astronomy happens. The first hint is often strange. The first explanation is often beautiful. The follow-up is often merciless. And slowly, the story either hardens into a discovery or dissolves into a more complicated question. In this case, the question has not dissolved. It has changed shape. Instead of asking only whether J1407b has huge rings, we have to ask, what kind of astrophysical event can produce a weeks-long, structured eclipse around a young star, and then avoid simple recovery? That is a broader and more durable question. It includes the ring hypothesis, but it does not depend entirely on the popular image of a giant Saturn. This is important for the viewer's imagination. The goal is not to shrink the wonder. It is to aim the wonder correctly. The most honest version of J1407b is not a finished poster of a planet with impossible rings. It is a cosmic investigation in which the best clue is a disappearing star. It is a reminder that astronomy does not always move from ignorance to certainty in a straight line. Sometimes it moves from mystery to model, from model to doubt, and from doubt to a deeper mystery. And in that deeper mystery, the original shadow becomes even more valuable. Because if the ring model is right, then the 2007 eclipse may be one of the rarest planetary formation clues ever seen. A huge disk around a young companion, perhaps with moon-carved gaps, caught by chance as it crossed a distant star. If the ring model is wrong, the event is still extraordinary, because something else must explain the same strange pattern. Either way, the star did not dim like an ordinary star. It behaved as if a hidden structure passed between its light and us. And for a few weeks, the invisible became almost readable. That is the quiet power of this case. J1407b does not ask us to believe too quickly. It asks us to look at how belief is built. First from a shadow, then from a model, then from every failed attempt to make the shadow confess its source. And somewhere beyond that young star, whether as a bound companion, a lost wanderer, or an unsolved event in old data, the cause of the eclipse remains attached to one of the most beautiful frustrations in astronomy. We know the light changed. We do not yet know exactly what changed it. The strange thing about a shadow is that it can feel more definite than the object that casts it. When J1407 dimmed in 2007, the light curve became a physical clue. It was not a rumor, not a drawing, not a dream of a ringed planet. The star's brightness changed, and the record of that change remained. Astronomers could measure it, model it, argue over it, and return to it again. But the source of the shadow remained out of reach. That imbalance gives the whole story its tension. We have the wound in the light, but not the blade. We have the pattern, but not the body. We have a possible map of rings, gaps, and dense bands, but not the companion itself moving clearly through a telescope image. In ordinary life, a shadow without an object would feel impossible. In astronomy, it is common. Most exoplanets were not first known as visible worlds. They were known as effects. A star tugged slightly by gravity, a star dimmed by a transit, a spectrum altered by an atmosphere. The universe often introduces its objects indirectly. It lets us see consequence before cause. J1407b belongs to that tradition. But it stretches the method to an uncomfortable edge. A normal exoplanet transit is repeatable. The planet goes around the star, crosses again, and the pattern returns. That rhythm builds confidence. Each repeated dip is like another signature on the same document. Over time, astronomers can measure the orbit, the size, sometimes even clues about the atmosphere. J1407's event was different. Its great dimming did not behave like a small, punctual planet on a tidy orbit. It looked like a one-time passage of something huge and structured. And without a simple repeat, the shadow became both precious and lonely. This is why the original data carries so much weight. It has to do the work that repeated events usually share. It has to suggest the size of the structure, the density variations, the motion across the star, and the possible geometry. It has to support a model without the comfort of many cycles. That does not make it useless. It makes it delicate. Imagine hearing one long, complicated sound in the night. Not a single knock, but a sequence. Scrape, pause, impact, echo, silence. Scrape again. From that sound, you might infer a machine, a person, an animal, a falling branch, or something moving behind a wall. The pattern matters, But until you see the source, your explanation remains exposed. J1407b is that sound in the astronomical night. The ring model is compelling because it explains complexity with structure. A giant disk moving across the star naturally produces changing levels of darkness. Dense rings block more light. Gaps let more light through. A tilted disk, a moving edge, an extended cloud of particles. All of these could create a sequence instead of a single dip. But there are other dangers. Young stars can be restless. Their surfaces can carry large star spots. Their environments can include dust. Their brightness can vary in ways older, quieter stars do not. The youth of J1407 makes the ring interpretation more plausible in one sense, because young systems are exactly where disks and moon formation might exist. But it also makes the star a less simple background lamp. The lamp itself may not be perfectly steady. That does not mean the eclipse was only stellar behavior. The event was dramatic enough and structured enough to inspire the companion and ring model. But it does mean the story must be handled with discipline. The viewer should feel the wonder, but also the scientific restraint that gives the wonder weight. Because the most cinematic version is not always the most honest version. The easy version says, a planet with rings larger than the solar system was discovered. The better version says, a young star underwent a weeks-long, highly structured dimming event, and one serious interpretation points to a giant ring or disk system around an unseen companion, possibly a planet-like object or brown dwarf. But the object has not been conclusively recovered. The better version is longer. It is less viral. It refuses to become a clean myth. It is also far more interesting, because it lets us watch science in motion. Not science as a final announcement, but science as a struggle between imagination and evidence. First comes the surprise. The star dimmed in a strange way. Then comes the model. Rings could explain the pattern. Then comes the scale. The disk would be enormous. Then comes the challenge. Where's the companion? Then comes the deeper question. What else could produce such a signal? Every step changes the emotional temperature. At first, the story feels like discovery. Then it feels like architecture. Then it feels like pursuit. Then it becomes almost forensic. Astronomers are not merely admiring a possible ringed world. They are testing whether the world can exist under the rules of gravity, whether its disk can survive, whether its orbit can explain the lack of repeat eclipses, whether later observations should have found it, and whether the original shadow might point to a different kind of event altogether. This is the part of astronomy that rarely fits inside a headline. A headline wants a noun. Planet, rings, super Saturn. Science often begins with verbs. Dimmed, crossed, scattered, failed to reappear, could be explained, remains uncertain. J1407b is built from verbs. The star dimmed. The model suggested rings. The searches constrained possibilities. The object evaded simple confirmation. The mystery widened. And behind all of those verbs is one quiet truth. The universe does not care whether its clues are convenient. It gives us partial evidence. It gives us signals mixed with noise. It gives us events that happen once during the small window when our instruments are watching. Then it leaves us to decide how much can be responsibly inferred. That is why J1407b should not be treated as a failed discovery, just because it is uncertain. Uncertainty is not the opposite of knowledge. It is often the shape knowledge takes before it becomes stable. A strange eclipse can still teach us about what young planetary systems might do. A proposed disk can still sharpen our understanding of how moons might form. A missing companion can still force better models, deeper searches, and more careful language. In a way, J1407b is most valuable because it resists becoming simple. It protects us from the comforting idea that the universe will always present itself in familiar categories. Planet, moon, ring, star, orbit. These words are useful, but they are human drawers. Young systems may spill across them. A giant planet can blur toward a brown dwarf. A ring can blur into a disk. A disk can blur into a moon nursery. A transit can blur into a one-time occultation. A discovery can blur into an open case. And somewhere inside that blur, the 2007 shadow remains. It is still there in the data, still cutting a strange path across the light of a young star, still asking whether we witness the planetary system in the middle of becoming itself. The answer may not be as simple as the myth, but the shadow is real enough to keep asking. If J1407b teaches one lesson, it is that the universe often gives us scale before certainty. The proposed ring system is enormous. That is the first thing everyone remembers. 90 million kilometers is a distance so large that ordinary ring language begins to fail. We can say rings because that is the closest familiar word, but the word brings the wrong image. It makes us picture Saturn's thin, bright bands, a graceful circle around a finished planet. J1407b asks for a different picture. Picture instead a young companion wrapped in a broad, flattened disk of material, not yet fully shaped into moons, not yet thinned into a delicate, mature system. Some regions may be crowded with particles, some may be sparse, some may be interrupted by gaps. The whole thing moves around a central body, and that central body moves through a larger relationship with the star. Nothing about it is still. The disk is not a ring in the decorative sense. It is a process. And this is where the story becomes more than an astronomical oddity. It becomes a way to think about how nature builds order from debris. A planet does not simply appear with moons arranged around it like ornaments on a shelf. Before moons are moons, there is material. Before orbits look clean, there are collisions, clumps, tides, resonances, and dust. Before a system looks inevitable, it is unstable. We usually arrive late. When we look at Jupiter, we see the result. Its major moons are already worlds. Europa has ice, Ganymede has size and structure, Io has volcanoes, Callisto has old scars. When we look at Saturn, Titan is already a world with an atmosphere, and the rings already have their famous beauty. We do not see the beginning. We see the architecture after the scaffolding has mostly vanished. J1407b may have shown the scaffolding. That possibility is what gives the 2007 eclipse its rare power. If the model is right, then the star did not merely dim behind a large object. It dimmed behind a moon-forming environment, a place where matter around a young giant companion was still being sorted into future structure. The gaps in the proposed disk become especially important here. A gap can be a clue that something inside the disk is disturbing nearby material. It can suggest a body clearing a path, though it does not prove one by itself. In a disk, gravity writes indirectly. A forming moon does not need to shine to reveal itself. It can sculpt the material around it, leaving absence as its signature. That is a beautiful idea. A moon announced by a missing strip of shadow. But it also has to be held carefully. The gaps in the model are not photographs of moons. They are features inferred from brightness changes. The interpretation depends on the model, the geometry, and the assumption that a ringed or disk-bearing companion caused the eclipse. If those assumptions change, the meaning of the gaps changes too. This is the discipline the story demands. We can be amazed without pretending every layer is confirmed. The known part is the unusual dimming event. The inferred part is the giant disk or ring system. The more speculative part is moon formation inside that disk. The unknown part is the exact object that caused it, its orbit, its mass, its survival, and whether the ring model is ultimately the right explanation. When those layers are kept separate, the story becomes stronger, not weaker. Because now the viewer is not being sold a fantasy, they are being invited into the actual frontier, where evidence is real, interpretation is powerful, and certainty is still being earned. The scale of the proposed disk also changes how we think about planetary systems. In schoolbook diagrams, Planets and moons look like finished objects moving through clean, empty space. But young systems are not clean. They are crowded with leftovers. They are full of material that did not yet become a planet, a moon, or a stable orbit. The early universe around a young star is not a clock. It is a workshop with gravity as the tool. J1407 is young enough for that context to matter. Around a young star, large disks and unsettled structures are not absurd in the same way they would be around a quiet, mature system. Youth gives the hypothesis room. It does not prove it, but it makes the idea feel physically connected to a real stage of cosmic development. A mature system hides its history. A young system still carries the evidence of construction. If J1407b's proposed disk was real, it may not have been meant to last. That is another way the Saturn comparison can mislead us. Saturn's rings feel iconic because they are present now, and we think of them as part of Saturn's identity. But a circumplanetary disk around a young companion may be temporary by nature. Its destiny may be to change, to fall inward, spread outward, thin, clump, form moons, or be stripped away. In that sense, the proposed rings of J1407b may have been magnificent precisely because they were unstable. They may have belonged to a passing chapter, a snapshot of becoming. And maybe that is why the object is so hard to find now. Perhaps the disk changed. Perhaps the geometry changed. Perhaps the orbit is longer than expected. Perhaps the companion is faint or massive or misplaced in our assumptions. Perhaps the event was caused by a different structure entirely. The uncertainty branches outward, but every branch still begins at the same trunk, the light curve. The star dimmed. The pattern was strange. The explanation had to be large. That is the anchor. Everything else is a ladder rising from it. The temptation is to climb too fast, to leap from a dimming event to confirmed planet, from a model to largest rings ever, from possible gaps to alien moons discovered. But good science climbs one rung at a time. It lets each statement carry only the weight it can support. And when we do that, J1407b remains extraordinary, not as a simple factoid, but as a rare lesson in scale, youth, and uncertainty. It shows us that planetary systems may pass through phases far grander and messier than the calm arrangements we see today. It suggests that moons may begin inside disks so wide they can eclipse stars for weeks. It reminds us that some of the most dramatic structures in space may be temporary, and that catching them may require luck as much as technology. A telescope did not capture a portrait. It captured an interruption. A star's light crossed a hidden structure and came to us altered. In that alteration, astronomers saw the possible outline of a young companion surrounded by a vast disk, perhaps in the act of becoming a moon system. That is why J1407b stays alive in the imagination. Not because it is proven in every detail, because for one brief passage, a distant star behaved as if a planet-sized world was carrying a shadow large enough to redraw our idea of rings. There is another way to think about J1407b that makes the story quieter, but also more unsettling. Maybe the real subject is not the object. Maybe the real subject is time. A ring system on the scale proposed for J1407b would not be a permanent monument. It would be a phase, a temporary arrangement of material caught between earlier chaos and later order. It might last long enough to cast a shadow across a star, but not long enough to become the kind of stable picture we expect from planetary systems. That possibility changes the emotional shape of the whole mystery. We are used to astronomy revealing things that feel ancient and durable. Stars burn for millions or billions of years. Planets orbit with patient rhythm. Craters preserve impacts from deep time. Even when we know the universe is changing, much of it appears still from the scale of a human life. But young planetary systems are not still. They are events. A disk around a young, giant companion may be reshaped in thousands or millions of years, sometimes faster in its outer regions. Particles collide. Material spreads. Gravitational tugs open lanes. Some debris gathers into larger bodies. Some falls inward. Some may be stripped away by the parent star. What looks like a structure from far away may actually be a moment in a long transformation. If J1407b had a huge disk in 2007, that disk may not represent the companion's timeless identity. It may represent one chapter in its youth. This matters because it helps explain why the search feels so strange. We want to find the thing as it was when it made the shadow. But the universe does not freeze itself for follow-up observations. The disk could evolve. The geometry could change. The companion could move somewhere hard to see. The material at the outer edge could be disturbed. The very feature that made the eclipse spectacular might be temporary. In that sense, the 2007 event may have been less like discovering a mountain and more like seeing lightning. A mountain waits. Lightning does not. It appears because conditions briefly align. Charge, air, distance, field, path. Then the sky closes again. The event was real, but you cannot return the next day and expect the same bolt to hang there for inspection. J1407b may not be that extreme, but the comparison helps. The eclipse could have captured a transient configuration, a passing alignment of star, disk, companion, and Earth. What reached us was not a portrait, but a crossing, a performance of geometry. The star was the lamp. The disk was the moving screen. Earth happened to sit where the shadow could be read. Change any part of that arrangement, and the mystery disappears back into ordinary starlight. This is one reason the title can mislead. The planet with rings bigger than a solar system sounds like a stable object sitting somewhere, waiting to be admired. It sounds as if we could point a telescope, zoom in, and see a gigantic Saturn glowing in the dark. The more honest image is more fragile. A young star, a one-time dimming, a proposed companion, a possible disk, a structure inferred from the damage it did to light. And perhaps, inside that disk, material that would later become moons, or vanish, or scatter, or fall into the companion forever. That is not less cinematic, it is more so, because it means the universe may have let us glimpse a process, not an object. It may have shown us an unfinished system during one of the short windows when its unfinishedness was visible from Earth. This is how many of the most important things in astronomy are found. Not as clean things, but as moments. A supernova is a moment. A transit is a moment. A flare is a moment. A collision leaves a momentary glow before cooling. A disk casts a shadow only when its plane, its motion, and our line of sight cooperate. We live in a universe of objects, but we discover it through events. J1407b sits exactly on that boundary. If the companion exists, it is an object. If the disk existed, it was structure. But what we actually received was an event, the changing brightness of a star over weeks. That event became the doorway through which all later speculation had to pass. The scale of the proposed disk also tells us something about the early lives of giant planets. A mature moon system looks calm because the violent sorting has already happened. The moons occupy their orbits. The empty spaces look natural. But before that calm, there may have been wide disks of material, crowded regions, gravitational clearing, and temporary rings so large they would seem impossible if we only judged by the solar system today. J1407b reminds us that the present is a poor guide to the beginning. If we only look at Saturn now, we might think rings are thin and elegant. If we only look at Jupiter now, we might think moons are simply there. If we only look at the solar system after billions of years of cleanup, we forget that order often begins as debris. A young companion surrounded by a vast disk would be messy, but not meaningless. The mess is the mechanism. Disorder is how gravity finds what it can keep. A particle collides with another particle. A small clump becomes a larger clump. A forming moon disturbs its neighborhood. A gap widens. A disk thins. A system slowly edits itself. Given enough time, the chaos begins to look inevitable. But during the editing, the system may be more spectacular than the final result. That may be the secret behind J1407b's appeal. It does not show us the polished universe. It suggests the draft version, the universe before it has cleaned the table. And because the draft version is temporary, it is hard to prove after the fact. The evidence arrives as a shadow. Then the shadow ends. The object moves on. The star brightens again. The data remains, but the original arrangement is gone. This is why the mystery feels almost personal. Human beings are good at loving finished things. We name planets. We photograph rings. We map moons. But J1407b asks us to care about a becoming, about a system that may never present itself again in exactly the same way. Somewhere around that young star, or perhaps only along our line of sight to it, something once arranged itself so that its hidden structure crossed the light. For a few weeks, the unfinished became visible. Then the star returned, and the universe kept the rest of the answer moving. By the time the story reaches J1407b, Saturn has already done something quiet to our imagination. It has trained us to think that rings belong close to a planet. It has trained us to expect beauty, thinness, symmetry, and light. In every famous image, Saturn appears almost ceremonial, its rings laid out like a perfect geometric thought. The planet seems complete because the rings seem complete. But Saturn may be the wrong teacher for a young system. Saturn shows us what a ring system can look like after time has refined it, after most of the ancient violence has faded, after the solar system has settled into a long, quieter age. J1407b, if the ring interpretation is right, points us towards something earlier and rougher. Not a finished ring system, but a wide disk of material still close to its formative meaning. That difference matters. A mature ring can look like a feature. A young disk can act like an engine. It moves material. It feeds growth. It transfers angular momentum. It creates conditions where clumps can appear, where gaps can open, where the future moons of a giant companion may begin as disturbances inside a field of debris. To call all of that rings is not wrong, but it is incomplete. It makes a living process sound like a frozen ornament. This is why J1407b feels so large in the mind. The proposed scale is astonishing, but the deeper scale is developmental. It is not merely a bigger version of Saturn. It may represent a different moment in a planet-like object's life. Imagine seeing a city not after its skyline is finished, but while the ground is still open. Cranes are moving, roads are incomplete, and the pattern of future neighborhoods is only beginning to appear. From far above, it might look chaotic, but inside the chaos, decisions are being made, foundations are being placed. Empty lanes already predict where movement will one day flow. A young circumplanetary disk can be thought of in a similar way. Not literally a city, not designed, not intentional, but full of physical consequences. A gap may mark the influence of a forming moon. A dense band may reveal where material is temporarily concentrated. A wide outer region may show the reach of the companion's gravity before the star begins to interfere too strongly. The whole disk becomes a draft of a system that has not yet become readable as planets and moons. If J1407b's proposed disk contained gaps, those gaps may have been the most important part. The spectacular headline is the size. The scientific poetry is the emptiness. A missing strip inside the shadow may say more than a bright band ever could, because absence can mean that gravity has already begun editing the disk. That is one of the great themes of planetary science. What is missing is often as meaningful as what remains. The Cassini division in Saturn's rings is famous because it is not simply blank. It is shaped by gravitational relationships. Gaps in protoplanetary disks around young stars can suggest forming planets. Cleared regions in debris disks can hint at unseen bodies. Again and again, astronomy discovers objects by noticing where material has been removed. J1407b belongs to that same family of reasoning, but at the scale of a possible moon-forming disk around a substellar companion. If the interpretation holds, then the star's dimming did not merely reveal material, it revealed organization. It suggested that the disk was not uniform, not just a fog, not just a cloud crossing the star, but a structured environment with internal differences. And structure is where the story becomes serious. A cloud can be accidental. A structured disk begins to look like a system. But the more structure we infer, the more responsibility the model carries. It must explain not just why the star dimmed, but why it dimmed in that sequence. It must explain how fast the object moved, how large the disk was, how transparent or opaque different regions were, and why the gaps appeared where they did. It must also survive the later silence, the missing repeat, the difficulty of direct detection, and the gravitational problem of keeping such a huge disk intact. The shadow invites a grand answer. The physics demands a careful one. This tension is what makes J1407b such a powerful documentary subject. It allows wonder to rise, then forces it through discipline. Every time the story becomes too easy, the evidence pulls it back. Every time the uncertainty seems to weaken the story, the original light curve pushes it forward again. The result is not a simple yes or no. It is a layered truth. Yes, the 2007 event was unusual. Yes, a giant ring or disk system is one of the most compelling explanations that has been explored. Yes, the proposed scale would dwarf Saturn's rings by a staggering margin. Yes, gaps in such a disk could, in principle, point toward moon formation. But no, the planet is not confirmed in the way many people imagine. No, the rings have not been directly photographed. No, the system is not known to be larger than the solar system. No, the gaps do not prove moons beyond doubt. No, the mystery ended with a neat discovery announcement. That may sound like less. It is actually more, because the honest version gives the viewer something deeper than a fact to repeat. It gives them a way to understand how cosmic knowledge is built under uncertainty. It shows that the universe is not divided neatly into things we know and things we do not. There is a middle territory, filled with evidence, models, constraints, and careful language. J1407b lives in that middle territory. And that territory is where imagination becomes scientific instead of merely spectacular. To imagine J1407b responsibly is to hold two pictures at once. In one picture, a young giant companion moves through space with a disk so wide that its passage across a star takes weeks, its rings and gaps writing a dark signature into the light. In the other picture, astronomers sit with the data years later, testing whether that first picture can survive every objection the universe throws at it. The beauty is not only in the possible rings. The beauty is in the testing. Because if the idea survives, it becomes stronger. And if it fails, the failure is not wasted. It tells us what cannot explain the shadow, what kinds of disks cannot survive, what kinds of orbits are unlikely, what future observations must be able to see. Science does not lose wonder when it becomes careful. It earns it. J1407b's proposed rings are enormous. But the larger thing is the method. A distant star flickers, a hypothesis rises, gravity interrogates it, telescopes search for the missing body, and the story becomes not a claim, but a living investigation. That is why the shadow still matters. It did not give us a finished world. It gave us a question large enough to orbit. The more we follow J1407b, the more the word planet begins to loosen. At first, the story seems simple enough. A planet-like object passed in front of a young star, carrying rings so huge they changed the star's brightness for weeks. That is the version that travels easily. It has a subject, an image, and a sense of scale. A planet, rings, a shadow larger than our expectations. But the actual science keeps disturbing that simplicity. J1407b may be a planet, but it may also be much more massive than what people usually imagine when they hear that word. Some versions of the model point toward a companion that could be closer to a brown dwarf, an object too massive to feel like a familiar planet, but not massive enough to shine as a true star. Brown dwarfs occupy one of astronomy's borderlands. They are sometimes called failed stars, though even that phrase can mislead, because it makes them sound like attempts at something else, rather than objects with their own nature. They sit between categories, and J1407b may sit there too. That possibility changes the scale of the story again. If the hidden companion is a brown dwarf or a very massive planet, then the proposed disk around it may not be a scaled-up Saturn system. It may belong to a different kind of formation environment, one where the boundary between planet building and star building becomes less clear. A brown dwarf can form more like a small star, from the collapse of gas, or in some cases, share processes with massive planets. Around it, material can gather into disks. Those disks can form companions. Nature does not always respect the names we place on its objects. It builds with gravity, mass, heat, dust, gas, and time. The labels come later. That is why J1407b is so useful. It forces the viewer to ask not only what was seen, but what kind of thing can own a structure like that? A normal planet? A young giant still surrounded by moon-building material? A brown dwarf with a disk? A rogue object passing between us and the star? Each possibility pulls the story into a different region of astronomy. If it is a giant planet bound to J1407, then we may be looking at an extreme version of moon formation. If it is a brown dwarf, we may be looking at a small, almost star with its own surrounding disk. If it is a rogue object, then the event becomes a rare chance alignment, a wandering body with dusty material crossing the face of a distant star. The shadow does not tell us which answer to choose by itself. It only tells us that something strange happened. This is where the narrative becomes bigger than J1407b alone. The object becomes a doorway into the problem of classification. We like the universe better when it fits into clean language. Stars shine. Planets orbit stars. Moons orbit planets. Rings orbit planets close in. Disks belong around young stars. But real systems can blur these boundaries. A giant planet can carry a disk. A brown dwarf can have companions. A moon-forming region can resemble a small planetary system. A ring system can be so wide that it stops feeling like rings at all. J1407b challenges the scale of the word around. When we say Saturn's rings are around Saturn, the phrase feels simple. The rings are close, thin, visibly attached to the planet's identity. But if a disk extends tens of millions of kilometers, around becomes almost geographic. It describes an environment, not a decoration. It may contain zones, gaps, density changes, and maybe the earliest beginnings of satellite formation. At that point, the central object becomes less like a jewel wearing a ring and more like a gravitational anchor inside a wide field of unfinished material. This matters because the public version of astronomy often focuses on named objects, planets, moons, stars, galaxies, but some of the most important science happens in the transitional material between them. The dust before planets, the disks before moons, the gaps before discovery, the shadows before images. J1407b lives in those transitions. Even its name feels provisional. The B suggests a companion to the star, as in many exoplanet systems, but the confidence carried by the name can be misleading. A name can make something feel settled before the science has fully settled it. Once an object has a label, the mind wants to treat it like a place. But J1407b is not yet a place in that way. It is a candidate, a hypothesis, a possible companion connected to an extraordinary dimming event. It has a name because scientists need language to discuss the model, not because every part of the model has become final. That distinction is subtle, but essential. A name is not a photograph. A name is not an orbit. A name is not confirmation. It is a handle placed on a possibility, so the possibility can be tested. And in that sense, J1407b becomes almost symbolic of how astronomy works at the edge of detection. We do not begin with full worlds. We begin with disturbances. We name them carefully. We build models around them. We try to break those models with better observations. The strongest ideas survive not because they are beautiful, but because they continue to explain the evidence after every attempt to disprove them. The ring model has beauty. Its survival is still being tested. That is the honest posture. And it is enough, because the uncertainty does not erase the larger lesson. Whether J1407b is ultimately confirmed as a ringed planet-like companion, revised into a brown dwarf disk scenario, or replaced by another explanation, the event has already done something important. It has shown how much hidden structure can be encoded in the dimming of a star. It has shown that young systems may contain circumplanetary environments far larger and messier than the rings we know. It has shown that the birth of moons may be something we can infer from shadows long before we can image it directly. And it has shown that the categories we inherit from the solar system may be too small. Saturn taught us what rings look like when they are close, bright, and mature. J1407b asks, what rings might mean when they are vast, young, unstable, and still becoming something else? Maybe that is the deepest shift. The question is not only whether J1407b is a planet with huge rings. The question is whether our word planet is large enough for the early lives of worlds. Whether our word rings is large enough for moon-forming disks. Whether our need for clean categories can survive contact with a universe that builds first and defines later. Somewhere in Centaurus, a young star once lost light in a way that still refuses to fit neatly into our drawers. And that may be why the shadow keeps growing in meaning. Not because it confirmed a simple object, but because it exposed the limits of simple words. At some point, every story about J1407b has to turn toward the instruments. Not because the instruments are more beautiful than the idea, but because they are what keep the idea honest. A giant ring system can live easily inside an animation. It can fill the screen with golden arcs and drifting dust. It can become a perfect spectacle. But in real astronomy, every spectacle has to pass through hardware. Lenses, mirrors, detectors, filters, noise, calibration, time. The universe does not hand us finished images. It hands us measurements. For J1407b, the original measurement was brightness. The star became slightly less bright, then much less bright, then brighter again, over and over, across a long and complicated event. That is a humble kind of evidence. No dramatic photograph, no visible planet, no ring plane glowing like Saturn's, just numbers changing with time. But those numbers carried shape. A light curve is not a picture, yet it can behave like one. If a small planet crosses a star, the light curve becomes a smooth dip. If a binary star eclipses another star, the curve has a different form. If dust passes in front, it may block more strongly at some wavelengths than others. Each physical event leaves a signature, not always unique, but meaningful. The light curve of J1407 was meaningful because it looked too structured to ignore. That structure is what allowed the ring model to rise, but the same dependence on structure also created the need for better observations. If a disk caused the event, then the disk might contain dust. If it contained dust, it might glow faintly in infrared or millimeter wavelengths. If the companion were massive, it might give off heat from its youth. If it orbited the star, it might be somewhere predictable enough to search. So astronomers began looking for the missing source in other ways. They were not merely asking, can we see the planet? They were asking, what should be visible if this story is true? That is a much more powerful question. A model makes promises. It says that if the hidden companion has a certain mass, age, orbit, temperature, and disk, then certain instruments might detect it under certain conditions. If those instruments see nothing, the model is not automatically destroyed, but its room becomes smaller. Some combinations of mass and orbit become unlikely. Some versions of the disk become harder to defend. Some comfortable explanations start to disappear. This is how a hypothesis gets sharpened. Not by admiration, by consequences. A telescope that finds nothing can still discover something. It can discover that an object is not bright enough to be seen at that wavelength. It can discover that dust is not where one model predicted it should be. It can discover that a candidate position does not contain the expected source. It can close doors. In popular imagination, discovery means finding a dot. In real astronomy, discovery often means eliminating the wrong darkness. That is part of why J1407b remains so fascinating. The follow-up searches did not simply deliver the triumphant image people wanted. They added pressure. They made the story more complex. They forced the ring hypothesis to carry its uncertainty in public. This is especially important because young objects can be deceptive. A young planet or brown dwarf may still be warm from formation, glowing faintly in infrared. Dust in a disk may emit at longer wavelengths. But how bright should it be? That depends on assumptions. How massive is the companion? How old is it? How much dust is present? How large are the grains? Is the disk still there? Is the object bound to the star or passing through by chance? Each answer changes what the telescope should see. So a non-detection is not a simple no. It is a statement with conditions. Nothing was seen down to a certain sensitivity, in a certain band, at a certain time, in a certain region. That may sound technical, but it is the difference between responsible doubt and lazy dismissal. J1407b lives inside those conditions. The silence after the eclipse is not empty. It is a map of constraints. Every search says, if the companion is here, it must be faint. If the disk is dusty in this way, it should have appeared, but did not. If the orbit is like this, a repeat should have occurred, but has not. If the mass is too high in certain regions, the object should have been detectable, but was not. The mystery is squeezed from many sides, and yet it does not vanish. The original event remains difficult. A young star dimmed for weeks in a structured way. The ring model explains many aspects elegantly. The proposed disk, if real, opens a window into moon formation, but later searches remind us that elegance is not enough. That may be the most valuable scientific lesson in the entire episode. A good explanation can be beautiful and still incomplete. Beauty helps us imagine. Evidence decides what survives. This is why the best version of the documentary should not treat caution as a footnote. Caution is part of the drama. The drama is not that scientists found the biggest rings ever and then closed the case. The drama is that the data invited one of the grandest ring systems ever proposed, and then the universe refused to make confirmation easy. The chase itself becomes the story. A dimming event points to a hidden architecture. Models reconstruct rings from starlight. Dynamics asks whether those rings could survive. Telescopes look for heat, dust, and motion. Each result changes the shape of what can still be true. The object does not step fully into view, but it also does not leave the stage. It remains behind the curtain of inference. And that curtain is where much of modern astronomy happens. We are learning to study objects too distant, too faint, too cold, or too brief to see directly. We read their effects, we test their consequences, we build pictures from partial signals, then revise those pictures when the next instrument disagrees. J1407b is not a weakness in that process. It is a pure example of it. The proposed rings may be real. They may be partly real. They may be the wrong solution to a real event. But in every case, the investigation has expanded what scientists ask about young planetary systems. How large can circumplanetary disks become? How long can they survive? How do moons carve gaps before they are visible? What kinds of one-time eclipses might reveal hidden structures? How many strange shadows have already passed through survey data, waiting to be noticed? That final question is especially haunting. Because J1407b may not be unique, it may only be rare, and rarity is not the same as singularity. Across the sky, countless young stars have been monitored imperfectly, at different times, with different instruments. Somewhere in those records may be other long, complex dimming events, other hidden disks, other unfinished moon systems caught by accident. The universe may be full of temporary structures that appear only when geometry allows them to write themselves into light. Most will be missed. Some will be recorded and misunderstood. A few will become famous enough to earn a name. J1407b is one of those names. Not a final answer, but a reminder that the next great planetary clue may not arrive as an image. It may arrive as a star becoming slightly darker, for reasons no one understands at first. A small change in a column of numbers. A shadow passing through a detector. A hidden system announcing itself by taking light away. The hardest part of J1407b is not imagining the rings. It is imagining how we would ever prove them. A ring system around Saturn can be photographed because Saturn is close. Spacecraft have flown past it. Telescopes can resolve it. Its rings spread wide enough across our sky, and the planet is bright enough that the system becomes a visible object. We can map divisions, waves, spokes, moonlets, edges, and shadows. Saturn gives us detail because it lives inside our neighborhood. J1407b lives in a different kind of distance. Its proposed rings are not something we can simply zoom into. They were inferred because a star changed brightness in a strange way. The object itself is hidden in the difficulty of exoplanet astronomy, faint beside a star, possibly cold, possibly distant from its host, possibly moving along an orbit we do not know, possibly not bound to the star at all. That means confirmation would require patience, luck, and the right kind of evidence. One way would be another eclipse. If the same companion crosses the star again with a similar structure dimming, the case would change dramatically. A repeated event would turn the story from a lonely shadow into a rhythm. Astronomers could compare the shape of the dips, measure the timing, refine the orbit, and test whether the same kind of disk structure appears again. But a repeat may not come soon. If the orbit is long, the next crossing could happen outside the short window of human monitoring. If the orbit is tilted slightly differently, the object might pass near the star from our viewpoint, but not directly across it. If the disk has evolved, the next event might look different. If the 2007 event was caused by an unrelated passing object, then there may be no repeat at all. A second path would be direct detection of the companion. A young, massive planet or brown dwarf might still glow faintly in infrared light from leftover heat. If a telescope could separate that faint glow from the star and identify a moving source consistent with the model, the mystery would become much more concrete. But that is a hard observation. The companion might be too faint, too close to the star, too far from the predicted position, or different in mass and temperature from what the model assumes. A third path would be detecting dust or disk material at longer wavelengths. If a large, dusty disk still exists, instruments sensitive to cold dust might find emission. That would not automatically prove every detail of the ring model, but it would give the shadow a physical counterpart. It would say, here is material where the hypothesis expects material to be. Yet even this path is conditional. Dust can be depleted. Grains can be large and dim. The disk may have changed since 2007. The object may not be where we expect. A non-detection can challenge a version of the model without destroying every possible version. This is why J1407b refuses simple closure. The evidence needed to prove it is difficult, and the evidence already collected is powerful but indirect. It sits in the awkward territory where a hypothesis can be scientifically serious without being finally confirmed. That awkwardness is exactly what makes the story honest. Because science does not move only through moments of announcement. It also moves through waiting, through monitoring, through old data being reanalyzed, through predicted positions being checked and crossed off, through better instruments making earlier ideas either sharper or impossible. J1407b may need that kind of time. The next generation of sky surveys may matter. Wide-field telescopes that repeatedly scan the sky can catch rare dimming events more reliably than older, scattered observations. If another young star suddenly undergoes a long, structured eclipse, Astronomers may recognize the pattern faster. They may already know to ask whether a circumplanetary disk is involved. J1407b, even unresolved, becomes a template for what to look for. That may be one of its greatest contributions. It teaches astronomy how to notice a certain kind of shadow. A strange light curve can become a search image in the mind. Once scientists have seen one possible giant disk eclipse, they can search for others. They can build algorithms to find long, complex, dimming events. They can compare young stars. They can ask whether J1407 was unique or merely the first dramatic case to receive attention. If more events like it are found, the meaning of J1407b changes. It stops being an isolated curiosity and becomes part of a population. One event is a mystery. Several similar events become a phenomenon. A population lets science ask new questions. How common are large circumplanetary disks? How long do they last? What masses host them? How often do they form moons? And under what conditions do they become visible as eclipses? That is how an uncertain object can still transform a field. Not by being fully solved immediately, but by teaching scientists what uncertainty might look like when it belongs to something real. The same thing has happened many times in astronomy. The first examples are often messy. They are found in incomplete data. Their explanations are debated. Their names become famous before their nature is fully understood. Then, slowly, more examples appear. The category takes shape. What once looked exceptional becomes part of a broader pattern. Maybe J1407b is the first hint of such a category. Or maybe it is a singular event that will eventually be explained in another way. Both possibilities are useful. If it becomes part of a category, then the 2007 shadow may be remembered as one of the first clues that moon-forming disks around giant companions can be detected through long eclipses. If it does not, then it will still have forced astronomers to refine their tools, their models, and their caution when interpreting complex dimming around young stars. A wrong hypothesis can still be productive if it is disciplined. But the ring hypothesis has not become simply wrong. It has become constrained, questioned, pressured, and complicated. That is a different state. It remains a serious idea under investigation, but no longer a simple internet legend. For a documentary, this is the turning point. The viewer begins with scale. The rings are huge. Then the viewer learns uncertainty. The planet is not confirmed. Then the viewer learns method. A shadow becomes a model, and a model becomes a set of predictions. Now the viewer reaches the deeper payoff. The story is not only about J1407b, it is about how we may discover the hidden childhood of moons around other worlds. Because moons are hard to catch being born. They do not announce themselves with fire. They gather quietly inside disks. They clear lanes. They disturb dust. They become visible first through the architecture they create around them. J1407b may have given us a shadow of that architecture. Not proof beyond doubt, but a clue large enough to change the question? The old question was whether there is a planet with rings bigger than Saturn's. The deeper question is whether stars sometimes dim because young worlds are carrying the raw material of future moons across our line of sight. That question is bigger than J1407b. It belongs to every young system in the sky. There is a quiet misunderstanding hidden inside the way we talk about large things in space. When something is big enough, we imagine it becomes easier to find. A giant planet should be obvious. A huge disk should reveal itself. Rings tens of millions of kilometers wide should not be able to hide. The mind assumes that scale and visibility are the same. J1407b breaks that assumption. Its proposed ring system could be enormous and still almost invisible except during the right crossing. Its companion could be massive and still faint beside the star. Its disk could have shaped a dramatic eclipse and still evade direct confirmation years later. In astronomy, size is only one part of detectability. Brightness, temperature, distance, contrast, timing, geometry, and wavelength all matter. A structure can be vast and hidden. That is one of the most important lessons of the story. We do not see the universe simply because things are there. We see it when energy reaches us in a form our instruments can catch. A cold disk may be dim, invisible light. A planet beside a star may be buried in glare. A ring system may reveal itself only when it blocks a background source. A moon may be known only through the gap it clears. Visibility is not existence. It is alignment plus physics. The proposed rings around J1407b, if real, were not discovered because they glowed like a sign in the dark. They were discovered because they may have crossed in front of a star. The star provided the light. The disk provided the interruption. Earth provided the viewpoint. For a short time, the geometry turned an invisible structure into a readable shadow. That is a very narrow kind of luck. If the disk had been tilted differently, the star might never have dimmed. If Earth had been slightly elsewhere in the line of sight, the event would not have appeared. If the survey had not been watching, the shadow might have passed unnoticed. If the data had been noisier, the pattern might never have been recognized. The mystery exists for us because several fragile conditions overlapped. This makes the event feel less like a simple observation and more like a cosmic accident caught by machinery. A young system did not announce itself to humanity. It happened to place one of its hidden structures between us and its star, and for a few weeks, the light carried the imprint. That imprint traveled across space to our detectors. Then the geometry moved on. The strange part is that this may be how many extraordinary systems are revealed, not by being visible all the time, but by briefly becoming aligned with something brighter behind them. The universe may contain countless cold, dark, unfinished structures that are not invisible because they are small, but because they have no lamp behind them. A shadow needs a source of light. Without the star, the proposed disk around J1407b would have been almost impossible to infer. With the star, it became a silhouette. The same object can move from hidden to detectable, not by changing itself, but by crossing the right background. This is why the star is not merely scenery in the story. J1407 is the screen on which the mystery appeared. Its youth matters, because young systems are more likely to host unsettled material. Its brightness matters, because the dimming could be measured. Its position matters, because Earth happened to lie along the path of the event. The star is not just the thing being blocked. It is the instrument nature used before human instruments ever entered the story. The telescope measured the star. The star revealed the shadow. The shadow suggested the disk. The disk implied a hidden companion. Every layer depends on the one before it. This chain is delicate, and that delicacy is exactly why overclaiming damages the wonder. To say simply, this planet has rings bigger than the solar system, collapses the chain into a slogan. It makes the story louder but smaller. It removes the method, the uncertainty, the geometry, the weighting, the non-detections, the possibility that the truth may be stranger than the first model. The real story is richer because it shows how a cosmic claim is assembled from fragile evidence. First, there is light, then less light, then a pattern in the loss of light, then a physical interpretation of that pattern, then a search for the object that could make it, then the pressure of every observation that does not find it. This is not weakness. It is the architecture of discovery. And the architecture matters because it teaches us how to read future shadows. As sky surveys grow more powerful, astronomy will no longer depend only on famous individual targets. It will watch the sky repeatedly, measuring brightness changes across millions and billions of sources. In those oceans of data, there may be other strange eclipses, long dimmings, jagged profiles, young stars briefly crossed by dusty structures, possible moon-forming disks that reveal themselves once, then vanish back into ordinary light. J1407b may be a preview of that future. It may teach scientists what to search for in the noise. A strange event that once looked like an isolated puzzle may become part of a new observational language. A long, structured dimming may say, "Look for a disk." A missing repeat may say, "Consider a long orbit or a chance alignment." A gap in the model may say, perhaps something is forming inside the material. A non-detection may say, revise the mass, dust, orbit, or even the entire explanation. That language is still being learned, and J1407b is one of its difficult sentences. The beauty of this is that the object does not have to be fully solved to be useful. It has already changed the kinds of questions astronomers can ask. Before the event, the idea of detecting a circumplanetary disk through a complex eclipse may have seemed remote. Afterward, it became a real possibility, something to model, debate, search for, and improve. A single shadow expanded the imagination of observation. That is different from fantasy. Fantasy asks only what could be spectacular. Science asks what could leave a measurable trace. J1407b sits exactly where those two meet. It is spectacular because the possible structure is immense. It is scientific because the claim came from a measured trace. The trace is the heart of the story, not the artwork, not the nickname, not the viral exaggeration. The trace, a young star dimmed in a way that suggested hidden structure. That is the honest foundation. Everything else must stand carefully on it. And when it does, the wonder becomes deeper. We begin to understand that the universe does not always reveal itself by shining brighter. Sometimes it reveals itself by going dark in a particular way. Sometimes the most important information is not the light itself, but the shape of its absence. J1407b may be a planet. It may be a brown dwarf. It may be a passing object. It may be a ringed companion, a disk-bearing wanderer, or the wrong name for a real but different event. But whatever it is, the lesson remains. Somewhere in the data, a young star carried a shadow so structured that it forced us to imagine a hidden system larger than our familiar idea of rings. And for astronomy, that is often how a new frontier begins. Not with an image, with a loss of light. The closer this story moves toward its ending, the more the original image begins to change. At first, J1407b seems like a story about size. A ring system so large that Saturn becomes small, a shadow lasting for weeks, a possible disk stretching across tens of millions of kilometers. The scale is what pulls the viewer in, because scale is easy to feel. We understand bigger. We understand vast. We understand the shock of comparing something familiar with something far beyond it. But the longer we stay with the science, the less the story is about size alone. A giant ring system is only the surface. Beneath it is a deeper question about how worlds grow, how moons begin, how young systems hide their construction, and how much of the universe exists in temporary forms that are almost impossible to catch. That is the transformation J1407b creates. It begins as a cosmic spectacle. It becomes a lesson in becoming. The solar system we live in is old enough to look settled. Earth has one large moon. Jupiter and Saturn have entire families of satellites. Uranus and Neptune have their own systems. The major structures have names, orbits, histories, and maps. We're surrounded by results. Because of that, it is easy to forget that every moon once had a beginning, and that beginning was not a finished sphere moving cleanly around a planet. Before a moon becomes a world, it may be material in a disk. Before it has a name, it may be a disturbance. Before it reflects sunlight as a body, it may carve a faint gap in debris. J1407b matters because it may offer one of the rare ways to see that earlier phase indirectly, not by photographing a moon being born, but by noticing how the raw environment around a young companion might block a star. If gaps in the proposed disk were shaped by forming satellites, then the 2007 eclipse was not only an eclipse, it was a possible record of moon formation written into the brightness of a distant star. That possibility is delicate. It depends on the model. It remains uncertain. It is not a direct discovery of exomoons, but even as a possibility, it widens the imagination. It shows that moons beyond our solar system may first reveal themselves not as points of light, but as patterns in the material around larger bodies. A moon can begin as an absence, a path cleared inside dust, a lane in a shadow. That idea is one of the most powerful in the whole script, because it reverses what the viewer expects. We think discovery means seeing something. J1407b suggests that discovery can begin by seeing where something has removed material, where gravity has organized emptiness. The same kind of reasoning appears across astronomy. Planets can be inferred from gaps in disks around young stars. Dark matter is inferred from gravitational effects. Black holes are recognized through the motion and radiation of matter around them. Exoplanets are found when they steal a small fraction of starlight. Again and again, the universe reveals hidden things through consequences. J1407b belongs to that grand pattern. It is a consequence looking for its cause. The cause may be a ringed planet-like companion. It may be a brown dwarf with a disk. It may be a chance alignment. It may be a different structure we have not fully understood. But whatever the final answer becomes, the method has already taught us something essential. A young star's light can carry the imprint of a hidden architecture too faint or distant to see directly. This is why the uncertainty should not be treated as a flaw in the episode. It should be treated as the emotional core. Certainty is satisfying, but uncertainty can be more revealing when handled honestly. It shows the viewer the difference between a viral claim and a scientific frontier. A viral claim wants to end the story immediately. The planet has giant rings. A frontier keeps the story open. The data suggests something extraordinary, and every explanation must survive observation, dynamics, and time. That open state gives J1407b its strange dignity. It is not just a fact to memorize, it is a case to follow. The proposed rings are huge, but the real scale is the scale of inference. From a dimming event, astronomers imagined a disk. From the disk, possible gaps. From gaps, possible moon formation. From the missing object, new constraints. From the constraints, better questions. Each step moves farther from the original starlight, but each step must remain tied to it, or the story drifts into fantasy. That tether is what keeps the wonder clean. And clean wonder is stronger than hype. Hype burns quickly. It inflates a claim until it becomes easy to share and easy to distrust. Clean wonder survives because it does not need exaggeration. J1407b does not have to be bigger than the solar system. It does not have to be confirmed beyond doubt. It does not have to prove alien moons. The honest version is already extraordinary. A young star produced a complex, weeks-long dimming event, and one serious explanation points toward a vast disk around an unseen companion, perhaps connected to the early formation of moons. That is enough. It is more than enough. Because if even part of that explanation is true, then the universe briefly let us see a hidden stage of planetary childhood. Not a polished planet with a decorative ring, but a gravitational workshop, a place where debris might have been sorting itself into future worlds. The word workshop is not perfect, because nature does not plan, it does not design, it does not build with intention. But as a metaphor, it helps carry the feeling. A young system is not a museum. It is active. It is changing. It is full of collisions, losses, captures, clearings, and accumulations. The order we admire later may begin in motions that look chaotic at first. J1407b, if real in the ringed form, would belong to that active stage. A stage our solar system passed through long before there were humans to watch it. That may be the deepest reason the story moves us. It is not only about another world, it is about our own past reflected elsewhere. The moons of our solar system were not always finished. Saturn was not always the Saturn we photograph. Jupiter's satellite system was not always settled. Earth's moon has its own violent origin story. Everywhere we see order now, there was once a more turbulent beginning. J1407b may be a distant reminder of that beginning. A reminder that the universe is not only filled with things, it is filled with things becoming things. And sometimes, if the geometry is right, becoming casts a shadow. By now, the Great Ring System has become something different from the image that began the journey. It is no longer only a circle around a hidden world. It is a question about evidence. It is a question about youth. It is a question about how the universe hides its most unfinished structures, and how much can be learned from a brief interruption in starlight. That is the mature version of the J1407b story, not the loud version. The mature version does not need to shout that a planet has rings bigger than the solar system. It knows that claim is too large, too careless, and too final. The mature version says something more precise and more haunting. A young star dimmed in a complex way for weeks. And one powerful interpretation suggests that an unseen companion may have carried a disk or ring system so vast that it dwarfed Saturn's rings and may have contained the raw architecture of future moons. That sentence is longer. It is also better because it keeps the wonder attached to the evidence. The difference matters. A misleading claim can create awe for a moment, but it damages trust. Once the exaggeration is exposed, the viewer feels the whole story shrink. But a careful claim can grow inside the mind. It leaves room for uncertainty, and uncertainty leaves room for thought. J1407b deserves that kind of treatment. It is not a simple trophy object. It is not a confirmed postcard world. It is not a settled planet waiting for us with a perfect halo. It is a possible object inferred from a strange event. And that event has become one of the most memorable examples of how a shadow can force astronomy to imagine something enormous. This is what makes the story useful at the end. It teaches a way of thinking. The first instinct is to ask, how big were the rings? The better instinct is to ask, what kind of physical system could create that shadow? The first question gives spectacle. The second gives science. To answer the second question, we have to hold many possibilities at once. A massive planet with a moon-forming disk, a brown dwarf with surrounding material, a companion on a long and difficult orbit, a disk that may require unusual stability conditions, a chance alignment with a wandering object, or some other explanation that has not yet become the final one. None of these possibilities is as simple as the myth, but all of them are more interesting than the myth, because they force us into the real frontier, the territory where objects are too distant to photograph easily, where events may not repeat, where models are necessary but vulnerable, and where the truth must be assembled from consequences. That is how much of modern astronomy works. We do not walk up to distant systems. We do not fly through them. We do not watch their histories unfold in real time. We receive signals, a spectrum, a flicker, a dip, a wobble, a faint glow in a wavelength our eyes cannot see. Then we ask what must have happened for that signal to arrive. J1407b is a signal with a spectacular possible cause. But the signal came first. That order must never be forgotten. A star lost light. The light curve showed structure. A model reconstructed a vast disk. The disk suggested rings and gaps. The gaps suggested the possibility of moon formation. Follow-up searches made the situation harder. Dynamics made the survival problem sharper. Non-detections made easy versions less comfortable. The object stayed elusive. This sequence is the real plot. It is not a straight line from discovery to certainty. It is a spiral. Evidence, interpretation, doubt, constraint, renewed question. Each turn does not erase the previous one. It refines it. It removes overconfidence. It keeps the mystery honest. And honesty is what allows the ending to matter. Because by the time the viewer reaches this point, J1407b should no longer feel like a piece of trivia. It should feel like an encounter with the limits of seeing. The object may be huge, but it is not easily visible. The shadow may be real, but its cause is not fully settled. The idea may be beautiful, but beauty alone cannot confirm it. The uncertainty may be frustrating, but it is also the place where the science is alive. That is a richer emotion than simple amazement. It is awe with discipline. There is also something almost poetic in the fact that the possible moon-forming disk is known through darkness. Moons are often imagined as bright companions, silver bodies hanging near planets. But here, if moons were forming at all, their earliest hint may have been absence, a gap, a cleared lane, a moment when the star's light returned because material was missing. A future moon, not seen as a world, but guessed from the empty space it may have made. That image carries the whole story. It turns the title inside out. This is not merely the planet with giant rings. It is the possible system where absence became evidence. It is the possible disk where future moons announce themselves by letting starlight through. It is the possible young companion whose greatest feature may have been visible only when it crossed a lamp much farther away. And if that interpretation eventually changes, the image still teaches us how science thinks. A model can be temporary without being foolish. A hypothesis can be uncertain without being worthless. A shadow can be incomplete without being meaningless. What matters is whether the idea explains the evidence, makes testable predictions, and survives contact with better observations. J1407b has not given us every answer, but it has given us a better question. How many young worlds carry disks we cannot see? How many moons begin inside shadows? How many temporary structures pass in front of stars only once, leaving behind a pattern that waits years for someone to understand it? How many strange light curves are still buried in survey archives, not because they are unimportant, but because no one has yet learned their language? That is where the story opens outward. J1407b may be rare, but it points to a method that could find more. Future surveys will watch the sky with greater patience. Future telescopes will see colder dust, fainter companions, subtler changes. Future models will test which disk structures can survive, which orbits make sense, and which shadows belong to forming moon systems rather than other kinds of stellar or circumstellar behavior. The 2007 event may become a prototype, or it may become a warning, or both. A prototype for how to search. A warning against believing too quickly. Both are valuable, because the universe is not only discovered through triumph, it is also discovered through restraint, through the courage to say possible when the internet wants confirmed, through the patience to keep observing when the first answer is beautiful but incomplete, through the humility to let a shadow remain a shadow until the object steps further into the light. That humility does not weaken the ending. It makes the ending last. Somewhere in the direction of Centaurus, a young star once dimmed, as if an enormous hidden structure crossed its face. The event ended. The star brightened. The object remained difficult to find, but the record stayed behind. A dark signature in a stream of measurements, still asking what kind of world, disk, or wandering body could write such a thing into light. Maybe J1407b is a ringed giant. Maybe it is something heavier, stranger, or more temporary. Maybe the final answer will surprise everyone. But for a few weeks, a star became a screen, and across that screen passed the possibility of a world still building its moons. A star does not remember the shadow that crossed it. It shines, varies, ages, rotates, and moves on through space. The event passes, the light returns, the system continues with whatever hidden bodies, disks, or debris fields it carried before anyone on Earth noticed anything unusual. But data remembers, somewhere in the record. The 2007 dimming of J1407 remains fixed, a strange sequence of fading and recovery, a wound in the brightness of a young star. It does not explain itself. It does not name the object. It does not tell us whether the culprit was a giant planet, a brown dwarf, a transient disk, or a wandering body crossing the line of sight. It simply remains there, asking to be interpreted. That is why the story should end not with certainty, but with a changed way of seeing. At the beginning, the temptation was scale. A planet with rings bigger than anything we know. A super Saturn. A cosmic object so dramatic that Saturn seems suddenly small. That image is powerful, and it is not wrong to feel its pull. Scale is often the doorway into wonder. But the real journey goes beyond scale. J1407b is not only a possible giant ring system, it is a case study in how astronomy wrestles with absence. The object is not clearly photographed. The rings are not directly seen. The moons are not confirmed. The orbit remains difficult. The follow-up searches have complicated the picture. Yet the original shadow still carries meaning. That is the central tension. A weaker story would hide the uncertainty, because uncertainty seems to soften the spectacle. A stronger story brings the uncertainty into the center, because this is where the subject becomes truly alive. The universe did not give us a finished answer. It gave us a pattern, and from that pattern, human beings tried to reconstruct an invisible architecture. That act of reconstruction is one of the great achievements of science. We live on a small planet under a bright atmosphere, far from the young star where the event happened. We cannot touch the disk. We cannot send a spacecraft to the companion. We cannot rewind the eclipse and view it from another angle. All we have is light, time, and the discipline to separate what was observed from what was inferred. Observed. The star dimmed in a complex way. Inferred. Something structured may have crossed its light. Modeled. A vast ring or disk system could explain much of the pattern. Possible. Gaps in that disk might point toward moon formation. Unknown. The exact nature of the object, its orbit, its mass, its survival, and whether the ring model is the final explanation. Those layers are not obstacles to wonder. They are the structure of honest wonder. Because when we keep them separate, the story becomes more durable. It does not collapse if one part changes. If J1407b is confirmed, the shadow becomes the first chapter of an extraordinary discovery. If the model is revised, the shadow becomes a lesson in how difficult young stars and hidden disks can be. If another explanation eventually wins, the 2007 event still remains one of the most provocative reminders that the sky can hide complex, temporary structures inside a single dimming. Every outcome teaches something. That is the gift of a good mystery. It does not merely withhold an answer. It improves the questions. And the improved question is no longer, how can a planet have rings that big? The improved question is, what stages of planetary birth are we only able to see when they briefly block a star? That question reaches beyond J1407b. It reaches into every young system where giant planets may be gathering moons. It reaches into disks of dust and gas where order has not yet settled. It reaches into the archives of sky surveys, where other strange dimmings may already be waiting, unnoticed, for someone to read them as more than noise. Maybe there are other J1407-like events scattered through old data. Maybe some have been missed because they happened once and never repeated. Maybe some belong to disks around planets, some to brown dwarfs, some to dusty clouds, some to young stars behaving badly, and some to categories we have not yet named. That is the future opened by the shadow, not a single answer, but a new sensitivity. After J1407b, a long, jagged eclipse around a young star no longer looks merely strange. It becomes a possible clue to a hidden disk, a possible glimpse of moons before they are moons, a possible sign that planetary systems can carry enormous temporary structures during their early lives, structures that vanish or change long before they become clean worlds in textbooks. This may be the deepest correction to the way we imagine space. The universe is not made only of finished things. It is full of transitions, clouds becoming stars, disks becoming planets, debris becoming moons, rings becoming gaps, gaps becoming evidence, shadows becoming questions, questions becoming searches. J1407b belongs to that chain of becoming. If the ringed companion interpretation is right, then somewhere around that young star, a massive object once carried a disk so wide that its passage across the star lasted for weeks. Inside that disk, matter may have been moving toward a future satellite system. Some of the material may have been temporary, some may have been lost, some may have gathered, some may have carved darkness into the light. If the interpretation is wrong, then the universe has given us a different puzzle, one that still demands an explanation worthy of the data. Either way, the event matters, because for a brief time, the hidden became measurable. A structure that could not be seen directly may have revealed itself by subtracting light, not by shining, not by glowing, not by announcing its presence with a clear image, but by becoming an absence with shape. That is the final image worth keeping. A young star in Centaurus shines across the darkness. Between that star and Earth, something passes. The star fades, recovers, fades again. Its light arrives here changed, carrying the silhouette of a possible system still under construction. Years pass. Astronomers search. The object remains elusive. The model becomes debated. The evidence becomes more precious, not less, because it is the only doorway into the event. And in that doorway, Saturn no longer defines rings. A ring is not always a thin, bright band around a mature planet. Sometimes it may be a temporary disk around a young giant. Sometimes it may be a moon factory. Sometimes it may be too wide, too unstable, too dark, or too brief to fit the word comfortably. J1407b may never become the simple legend people wanted. It may become something better. A reminder that the universe is larger than our categories, more temporary than our diagrams, and more subtle than our desire for instant certainty. A reminder that some worlds are first known not by their light, but by the light they interrupt. A reminder that the birth of moons may be written not in brightness, but in carefully shaped darkness. The star does not remember, but the data does, and somewhere inside that old dimming, a possible world still crosses the light, not as a confirmed monument, not as a finished answer, but as one of the most beautiful, unfinished questions astronomy has ever caught in shadow.